Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles. You need key cutting equipment. You need diagnostic tools. Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back, and again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Hey, have you ever been faced with the challenge of sourcing, installing, and programming a used control module in a vehicle? I know a lot of us have. It seems to be happening more and more often today with the volume of control modules on vehicles, the cost of some new ones, or even the availability of new control modules. In some cases, used may be the only option. So what do you do here? I strongly recommend checking out SJ Auto Solutions and Tommy Oliva. Tommy offers a cloning service for used control modules to make these things plug and play for the vehicle that you're working on. In a lot of cases, he is also able to source the control modules if you're unable to locate one for the vehicle that you're working on. But once you get connected with Tommy, he's going to offer fantastic support from start to finish to make sure that that control module is going to work in your application. He's also got tech support that he offers through his website, along with some free resources there as well on information about used control module programming. So make sure to check out SJ Auto Solutions. I can't recommend that enough. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's episode. I've got another case study for you, so thanks for joining me. Sit back, relax, and we'll get into this one. I'm going to continue with my theme, go for this as long as possible, and I don't think it'll be that hard, of talking about cars that kind of get beat up on and struggle with. This one was no exception. We made the wrong call on this one initially, and we did make it right, but it was a struggle. It was a battle. It beat us up, and that's why I'm sharing it. So let me set you up on the scenario here. This is a 2014 Ford Fiesta with a 1.6 liter. This was at one of the shops we service, and we were initially called in for what they called a no crank and obviously no start. I don't know why we call them no crank, no start. It's a no crank. Of course it doesn't start. They did say the starter would sometimes engage or engage a little bit. They weren't really sure, but this thing won't start and it doesn't seem to want to crank. They already put a starter in it. They already put a battery in it. They cleaned up the battery cables. They're not quite sure what's going on with this one. They don't have any codes to go with, and they don't have any direction. So, okay, we'll come in and check this one out. Now, I was actually on vacation when we got called on this one. And so my employee ran out there to check this one out. And, you know, most of the time on a no crank, I'd say it's fairly straightforward and fairly easy to figure out what's going on, right? Okay, the starter's not activating. Why not? What's preventing the starter from activating? Shouldn't be, too terribly difficult. But again, that's why I'm talking about this one on here. So what he ended up finding when he got to this vehicle is that the starter would engage on this one, but it would only do so very briefly. You would hear the starter solenoid close its contacts, and you'd actually hear the starter engage, meaning that the drive gear is moving out and engaging the flex plate. but that's about it. And then it would release. So it's not even turning over the motor. It's just it kind of a loud click, and you could see the engine move just a hair, right? You see that movement in the engine when the starter engages the flex plate, but it wasn't cranking, and it would release immediately, right? And so you hit the key, it does that little clunk, and then it releases the starter. And so that's what they were after, of course. Okay, so it's not a complete no crank, right? We're getting a signal to the starter, but it's releasing for some reason or another. Okay, cool. So we should be able to figure this out, right? And I'm walking you through the process that my employee took when he initially looked at it. Of course, we're checking things like battery connections. Obviously, does the starter work itself? The basics when you have a situation like this. And immediately this kind of struck Steve as a voltage issue, as it would many of us, right? Is there just not enough voltage in the system? Is there voltage drop somewhere in the cables? Is there something wrong with the starter? Something like that, right? It's like it's engaging but then releasing. So does his basic checks, right, to make sure that the battery's up to snuff. We have a jump pack on there, checking cables from what we can tell up under the hood, and everything looks fine there. So one of the things he wanted to try was, I'm just going to jump the starter manually at the relay point and see what it does. And again, this is a test I would have done, a test many of us would have done in this point. Obviously, you can go down to the starter, but I just want to see, can I try and jump the starter at the relay and what happens? Is it the same thing? Because if it's the same thing, well, okay, I'm going to head towards the starter. If it's not, then I'm going to look at the control side of this relay, right? And I guess in my head and Steve's head, is the starter being released because we have some type of voltage issue, or is it a commanded release by whatever circuitry controls the starter relay? And that's kind of the direction that we want to go. So again, pulls out the starter relay and jumps the two terminals that are the load side for that relay that feed the solenoid for the starter. When he does that, the engine cranks over normally, right? The starter engages and it does not release, and you can watch the engine turn over and turn over and turn over. And I think he found out if you put the key in the forward position and do this, you can actually get it to start and run. Okay. And this will happen every single time. So now we know we're either dealing with, well, maybe a starter relay issue, but either that or it's on the control side of this relay, because you put the relay back in and it does the same thing. It just goes clunk and then it releases the starter. So he does his checks to figure out, okay, and swapping the relay is the first thing that he did, and that didn't change anything. So then the next thing that he's going to look at is the circuitry that controls the starter relay, right? The control side of the coil to activate that relay. What's going on there, and are we losing something on that side that's causing the starter to release? Because it sure seems so, right? And we're not concerned about the voltage of the starter. We're not concerned about the ground going to the starter, any of that stuff, because we can jump this thing and it cranks normally. So looking at the diagram, both of the control wires for the starter relay go right to our engine control module on this one. And so it controls both power and ground. And I think one was constant and the other one was switched. I'm pretty sure on that. I don't recall which one was which. Doesn't really matter for this. They both go to the ECM. And obviously when you hit the key and you've got it in the correct gear, this thing should crank over until you release the key or the engine starts. And swapping the relay didn't make a difference. So when we're looking at the control side of this relay, what he ended up finding out was that the ECM was releasing the starter relay, right? It was turning off. Again, I should look this up to see which one switched, but whichever switched power or ground it was to the relay, it would just release it, right? It would initially apply it, and that's when you heard the starter engage, but then it would go away and the starter would release. So this is a commanded release of the starter. Maybe commanded is the wrong term to use there, but the ECM is releasing it, okay? So we need to figure out why, and we're going to start looking at data pits. And he had done an initial scan on this and didn't have any codes that seemed relevant to this issue. Checked it again, didn't see any codes that were relevant to this issue. Right, codes in other modules, but nothing in the ECM. But we can look at some scan data to try to help us figure out, what is causing this. And the basic ones are going to be things like, well, number one, does the ECM recognize that the transmission is in the correct gear, right? That's something that could stop it from happening. But also communication with the module, right? The module could be dropping offline. The ignition switch input, right? How does the PCM recognize that we're trying to crank the engine over? Is that something? Potentially an anti-theft, but I actually don't think that an anti-theft would be even really something to look at here. I don't know that an anti-theft issue would cause a starter to release after it had already been engaged. So that's not really something, but I mean, those are the kind of data PIDs that we can take a look at just to see what's happening here. And as far as he could tell on all the data PIDs, voltage to the module, key position, park neutral position, all that stuff, it seemed to be okay even when the ECM would release the starter relay. And he went back and forth with this quite a bit to really look at it, and he didn't see anything. And there's no codes, and it's for sure the ECM releasing. He even went to the ECM on those two wires that go to the control side of the starter relay, and it's the same thing right at the module. And he could actually crank the engine over using those control wires at the ECM, right? If you send power and ground, the starter relay activates, and the thing just continues to crank when you do it there. So, right, all of that is good. The control side of the relay itself, the load side of the relay, the starter, all of that's functional. But for whatever reason, again, the ECM's deciding to release this starter relay. And he called me on this, and I was out of town, and I tried to help him out the best that I could, right? My girlfriend wasn't too happy. We went down and we stayed on the beach, and she's like, "You're working again?" But, I feel really bad leaving my guys hanging. I told him, "Hey, you got a question on something, just give me a ring. I will offer you my best advice." And so I'm down there on the beach trying to, look through some service info and say, let's see, what can we look at here? And I told him some data PIDs, like, okay, check the starter command relay, check the park position, this and that. That's really all I can think of off the top of my head. Nothing rings a bell as far as a problem like this that I've seen in the past. There's no hits on Identifix. Just double check everything that you've tested so far. And right, I'm not there, so a lot of the detail I'm giving you right now is, after we've been through it. But he tried to fill me in the best that he could. And I was like, well, you got to have these inputs in order for the ECM to crank. And if any of those are missing, we address it. If not, let's start looking at powers and grounds to the ECM. Like, that's our next step, right? Maybe we're losing a ground, right? We can crank the starter, but it doesn't mean that it's not a ground issue or not a power issue, something like that. It may be communication, but we don't have any communication codes. So he goes through, and ends up checking exactly that, the powers and the grounds to the ECM. And we load tested them, and he load tested them with a headlight bulb, and we checked them during cranking, and everything to the PCM is there the whole time, right? And all the inputs to crank, the supply of power and ground to it, they're all present the whole time. Nothing ever drops out. They can all carry a load on those circuits. So he's not really getting anywhere with it. And he talks to me and says, hey, this is what I found. Okay, again, just double check everything. Look at this real closely. Yeah, we don't see anything. I was like, okay, well, this might be an issue with the ECM. I can't be there to check all of these circuits to see all this stuff with myself, but I trust my employee to make the checks correctly, and he's seeing what he's seeing, and we don't see any other inputs to this ECM that would cause it to release the starter. It's just doing so for some reason. So we ended up calling an ECM on it. Told the shop, get an ECM. We'll come back. We'll program this. So they did that. They ordered a new ECM for it. Get it installed. We come back, program it, and it's the same thing. It didn't change anything at all. And I got that call. I'm like, okay, well, it's just going to have to be something that waits until I get back, and I will take a look at it personally, and we'll see if we can get through this. So, apologize to the shop and say, hey, we're going to take care of you. We're going to take care of you either way. We'll get this solved, and we'll eat the module. You don't have to worry about that. Right? It's our bad call, and I'm happy to do that if we make a bad call on something. I'll pay for the parts. I'm not going to have them eat the part or the customer eat the part because I made a bad call. Absolutely not. But, mistakes happen. So get back into town, get on this thing. I get down there and experience the exact same thing. Everything is exactly like Steve was telling me it is. All of the tests that he did, essentially I did the same thing just to verify, like I want to see it myself. I can crank that starter over by jumping that relay. It cranks over, seems no problem, right? I kind of drained their battery down, so I hooked up my jump pack and still same thing, cranks over. Okay. I verify that the ECM is definitely dropping out the relay control for sure. There are no codes. There are no data PIDs in the ECM that can help me. And there is about a gazillion data PIDs in these things. Ford go a little overboard, but I'm looking at the actual start relay command, and this was interesting. And this I wasn't clear on, number one, to tell Steve to look at or to even know that it was necessarily there. I don't know all the data PIDs off the top of my head. There's a starter relay data PID in the ECM, and that actually switches. And this is one thing that you can see in the ECM that, hey, it's commanding or it is intentionally releasing the starter relay because it goes from on when it first hits the starter to off. Okay. Well, and that's not a huge help because we know that's happening. We know it's releasing it, but it's there in scan data. This isn't some necessarily like weird circuit issue with those command wires. This is the ECM's logic telling it that, hey, I'm releasing this starter. Okay, well, I guess that's something. And of course, again, I want to look at the voltage data PIDs, the key position data PIDs, the park neutral data PIDs, and look to see, is there any kind of dropout on these while this is happening? Is it losing something? An important input to it that would prevent it from cranking, and I don't see any. And again, I checked the anti-theft stuff, even though I didn't think that was related. Again, all of that looks fine. I don't see anything scan tool wise that's causing this dropout. And hindsight here, I really would have liked to have taken a closer look at one of the data inputs. Maybe I would have seen something, but I'm pretty darn certain that I looked at it and I graphed it and I didn't see a dropout. And I'll get back to what that is. You'll hear what the actual solution was to this. But I went back and forth checking a few things and checking powers and grounds to the ECM and didn't come up with any solution. And eventually what I got to was I was really trying to make myself a list of, okay, because the ECM is deciding to release the starter, what are the things that could cause it to do this? Like, right, under normal circumstances, what are the things that are going to change or the inputs that are important to the ECM to allow it to crank or not? And obviously key position is an important one. And this is a bladed key, if I didn't mention that. But the key position is important, and that looked okay in the scan tool, but also the park neutral position is really important on these vehicles and in any vehicle, right? That's not anything new, but it is an input to that module. And so again, I had already really kind of looked at the crank inputs as closely as I could have and looked at them on the circuit and didn't see anything. But the park neutral input I really hadn't looked at too much. And reason being is it showed fine on the scan tool and the ECM as far as what I could see. But there's an independent circuit that goes between the TCM and the ECM to indicate the park neutral position, right? Are we in park or are we in neutral? And the TCM, which this is one of those automatically shifted manual transmissions, right? The DPS6, these things are just garbage, and they have the transmission control modules bolted to the case of these transmissions. And a lot of issues with these transmissions, a ton of issues. This isn't, one that I've seen is an issue here. But I start looking at this circuit, and again, there's an independent circuit here of park neutral on this thing. And I hadn't really looked closely at this circuit. Looked at the data pit. I didn't look at the circuit, and I don't think Steve did either, or the shop. And once I've got the scope out here and I'm looking at stuff, I did see a dropout on this wire. Okay. And so this is just a simple voltage on this wire, like a real simple on or off, depending if you're in park neutral or not. And that's the indication to the ECM whether the transmission is in the correct gear range to crank. Okay, well, hey, we're finally on to something here. Now, again, why I didn't see this in my scan tool, I don't know. It was my scan tool I was using, and yes, it was an aftermarket one that I was using here. I did not have IDS on this thing when I was graphing. Hindsight, maybe I should have. I never even did try it, but I have something here to go with. So I don't really care at this point. I just need to follow this and figure out, okay, why is the park neutral dropping out? And it makes sense why the starter's releasing, because it doesn't see it that it's in the correct gear to park, to crank anymore. All right. So now I really want to focus on my TCM, transmission control module. And there wasn't any codes in this thing either. And I go into the data PIDs for this control module at this point, because I want to see, do I see anything reflected here that's indicating that, hey, we're leaving park or neutral. Now, one thing that I noticed here was that the Prindle on the dash that indicated the gear position would go blank when you were cranking, right? So if you held that key forward, it would just go to no gears indicated. And I thought in the moment, I was like, well, this must be part of my issue. It's like losing its capability to understand if it's in park or neutral. I did find out, and I want to make this clear, that's normal. That happens when you crank it, even if everything is good. So don't go off of the Prindle going blank as a problem in this one. It's not. But I did look at the data PIDs, and this was a little bit confusing. This is where this one was just odd. This is a strange one. There's a range sensor on this transmission that sits on the top, and it's an independent sensor, and it feeds the TCM through a few circuits. And it actually outputs like a duty cycle to the transmission control module to indicate the position of the transmission, park, reverse, neutral, drive, low, right? The status that this output, and there's a number of data PIDs in the TCM for this, never changes, right? You can crank it, it releases the starter. That never goes away from park, because that's what I was thinking. I was like, maybe this is like a range sensor issue or something like that. Never changes. And I should note, I never lose communication with the TCM. Nothing ever drops out scan tool side. Again, don't have any communication codes, have nothing like that. Okay. And I'm looking closer. I'm looking at all the data PIDs I can here, because I like to get what I can from scan tool info before I go digging in circuit wise. I want to know, where am I losing this? Is it internal to the module? Is it dropping out for some reason? Or is there something else going on? And that's what I was trying to determine. Was it losing something from the actual range sensor? Is this in the TCM? Which direction are we going? And again, I don't see anything there. Now, scouring the data PIDs, this took me a little while. I did find two data PIDs that would actually drop out and correlate with my problem. Okay. So the first one here, the abbreviation to this is TR crank in the TCM. And this says transmission range input allowing start. And that data PID, when this thing would release the starter, would go to no. Otherwise it would be yes, right? If you turn the key on, it's in park, it says yes, meaning that the TCM is allowing cranking. If you put it in reverse, it says no. But if you put it in park or neutral, it says yes. And you go to crank it and it still says yes. And then you'd see it drop out and say no on the scan tool. And it correlated right along with my problem. So again, I'm definitely on to something. The dropout I was seeing on this circuit between the TCM and the ECM seems to be accurate. Oh, and maybe I should note, Ford calls this thing a PCM. I'm calling it the ECM, right? I call a PCM if it's a powertrain control module and does both the engine and trans. And then if it's separate, I say engine and transmission, just to be clear. But if you look up the diagram, Ford calls it a PCM still. Whatever. Anyways, the TCM here is my focus. And I finally see something happening here. All right. So why is this? Because I got the graphs right next to each other, and the info from the range sensor does not change. So is this a module issue? Is there something up with this module? And once I saw this happening and the way that this thing was acting, right, it would never drop out until you hit the key. The starter was definitely the key to this actually happening. And I was just thinking, I was like, well, okay, well, this could be a module, but are we back to like a voltage drop issue here? Something with the starter. And I had really kind of eliminated that from my mind because, like I said, initially we could jump the starter and this thing could crank all day. But is there something with the starter engaging that's affecting voltage in the system somewhere, somehow? And now I'm kind of back to thinking that, where I had totally eliminated that from my mind because you could jump the starter and it would crank all day long. And again, I checked my powers and grounds to my ECM when we were focused in on that and never found any issues or with the grounds there either. But now I'm back in that mindset. And again, I'm sitting in the driver's seat looking at the scan tool still. I haven't even gone to the TCM yet. But I'm looking at other data PIDs to see, is there anything that can correlate with this that might clue me in as to what's going on. And one of the ones I pulled up was the actual module voltage data PID, right? So this is the voltage that the TCM reads. And I tried this thing a number of times. It seemed okay at first, but every once in a while it would drop out along with that TR crank data PID dropping out. And they were right along with each other. And the module voltage that it was getting was dropping out, and then it would come back after the starter released. And so I'm like, there's got to be some sort of voltage drop issue here. Now, I'm not losing communication with the module. There's no codes in the module for loss of voltage or under voltage or anything like that, but I see it drop out very briefly on the graph on my data PIDs, and it again correlates with it releasing it's okay for the engine to crank. And it's really fast, right? It's like just a tiny little drop on the scan tool. And I'm guessing maybe that's why I didn't see it in the ECM. I don't know. Anyways, okay, let's check powers and grounds to this module, which isn't necessarily the easiest thing. Number one, because of the location, okay, we can lift it up in the air. But the connectors are kind of a pain to get to the actual like wires as they go in to the module. Now I can load test the powers and grounds, and I don't think that would have gotten me anywhere with this. And the reason I didn't do that here, right? Normally if I'm suspecting a module, I'm going to take headlight, bulb, 9000 series, load those powers and grounds. The reason I didn't do that here is because, again, I'm thinking it's something to do with the starter. This never changes its status until the starter actually engages. Something with the starter, and I'm thinking voltage drop. There's something going on here. So what I did was I found the TCM ground. I looked at the diagram. There's like 4 wires that provide ground to the TCM, but they all go to the same place. And this is a ground on the case of the transmission, which is up towards the top of the transmission facing the front of the vehicle, right? So all 4 wires go into one. And I'm like, hey, before I start pulling these connectors apart or anything like that, because I'm suspicious of the starter, right, which is going to use the case of the transmission and the engine as a ground, how about I do some checks here and look for, do we have some voltage drop going on here? And so this is an easy check to make. And here's how you do this. You take your scope, and you could do it with a meter too if you wanted to, but the scope is nice because you can pause it and zoom in, zoom out, and take one lead, right? One channel, one lead. You could do this with a U-scope if you wanted to. I had my Pico out at this point. I'm getting serious. And you take the colored lead and you put it down on the ground that you want to measure, and you take the black part of that same lead and you put it up on battery negative. Okay. Now, when I normally crank this thing, maybe I could see a little bit of voltage drop, a few tenths of a volt maybe, while you're cranking, right? You're going to see some voltage drop. That's a lot of amperage moving through that circuit, and you'll see some voltage drop. But I don't want to see too much. And what's too much? If I see a couple volts at least, I'm going to be concerned about the voltage drop happening here between the negative cable and the case of the transmission, right? Those are both ground. They should both stay ground. You shouldn't measure a voltage difference between them, or at least not much, even while you're cranking. Now, here's what I saw when I cranked this thing. This thing would spike to about 9 or 10 volts of difference between this. And this wasn't like a quick little blip on the scope, right? Sometimes like you'll see like a little jump in voltage. You're like, oh, what's that? And you zoom in, and you zoom in, and you zoom in, and you can't see a separation. It's just a line as far as you go in on the time base. But this was like a measurable amount of time. It actually created a little tiny square wave, if you will, of the voltage drop between these 2 points. I'm like, well, this is my problem, right? I'm getting 10 volts of voltage drop between my negative cable and the case of the transmission. Okay, and again, this where I'm measuring is where the ground for the TCM is bolted to the case of the transmission, and so I made sure that it wasn't at that point the issue was, but I wasn't thinking that was the case because I was like, it's when the starter hits. That's when this is happening. Okay, so why? This is now, it should be easy. I'm just going to look to see, okay, how does the negative battery connect to the transmission case? And it's a little goofy in the way that it does it on this one. It actually goes from negative battery terminal to the body of the vehicle, and from the body of the vehicle to the transmission case back by the CV axles, or where they go into the transmission case. All right, and there's just one bolt that bolted onto the back of the transmission here. Okay, well, that's, I can use my scope and start going down the path, right? Is it a voltage drop from the battery to the body? And I found out it wasn't, but it is from the body to the case. Okay, so I get down to the bolt, the big negative cable onto the bottom of the transmission, and I could visibly see. I'll put a picture in the Facebook group. You could visibly see where it looked like this thing was acting as an arc welder between the bolt itself and the cable. Right. And this was before I even took the bolt out or did anything with this cable. I'm like, well, this is where my problem is. There's a ton of voltage drop happening here. And before I even took it out or did anything with it, I took my jump cable. Like, I actually have a set of jumper cables in the van for jumping dead batteries. And I clipped from the case of the transmission up to the negative battery cable, and I cranked it, and it worked. It started, it cranked all day long. There was no issues. And normally a problem like this, it shouldn't be as much of a problem as it was, right? If we have a voltage drop like that, right, wouldn't it have stopped the starter from operating? Well, it obviously didn't, because like I said, and again, I'll put up pictures. This cable end was just toast. It was all black. And the bolt, actually, interestingly enough, when I took the bolt out, the threads like pulled out, and I was wondering, I was like, well, was it because this was stripped? But I actually think that the voltage drop occurred between the face of the eyelid of the cable and the case of the transmission, and the current for the starter was going through the bolt into the bolt hole in the threads, and it just torched this thing. So you got to see it. It's pretty wild. But going back to, like, shouldn't this have been a problem that would have been easily identifiable? Right? Why didn't I look at this first? Why didn't we look at this first? This is kind of a normal thing. We see battery cable issues all the time. We, both me and Steve, completely went away from this because when we jumped the starter relay, the thing cranked. Like, no problem. Now, after the fact, hearing it did crank a little bit faster when we fixed this bolt. We had to clean the connection. We actually moved it to another bolt because the threads were stripped out of the one that I took out. But anyways, it did, okay, so it cranked a little bit faster, but it wasn't that far off. It didn't sound terrible, and it started, right? If you put the key in the on position and you jump the starter relay, it would start. So it's not like it was cranking too slow to do anything, but when we would do this, we'd have a massive voltage drop on the case of the transmission. And that was enough to affect the TCM, but not to drop it off communication, not to kill it, not to set codes, but something with that module. It goofed up something in that module enough to release the park neutral position. I don't know what exactly. I can't explain that, but that is what was happening. Is that voltage drop on the ground for the TCM was causing it to stop saying, hey, I'm in park and neutral, and then the ECM released the starter relay. And it was the voltage drop, that big hit of the starter, right? If you look at the amperage spike when you first kick a starter in, it's huge, right? And that's when your voltage drop is going to be the most. Okay, and my guess, my assumption is that voltage drop was real. It was definitely, obviously it was real. It was there, but it wasn't enough to completely stop the starter, meaning that when I jumped it manually, it could still engage. And then once it engages and starts moving, that amperage is going to drop down. And we were okay with the amount of current moving through this thing. Right, if you think about a resistance or a restriction to electrical flow, it's more of a problem as you have more current. It's less of a problem as you have less current, right? And so as that starter motor starts moving, we're able to move electrical current through there without an issue, right? So it gets over that initial hump. Maybe it's not easy. And honestly, it didn't sound bad. But once it gets past that, okay, we're going to keep cranking. But that initial voltage drop was enough to affect the TCM that's using that case for a ground as well, right? That module was more sensitive than the starter itself, surprisingly enough. If you would have told me that's what was going on with this one and that's how the problem presented itself, I don't know if I would have believed you, but I saw it. That's what it was for sure, because we fixed up that ground and it was fine. It cranked and started and there was no issues. So that one was pretty crazy. I mean, looking back on it, maybe there's some things that I should have saw. I'm really wondering maybe if I had pulled out IDS, I would have seen the park neutral dropout in the ECM. I mean, if I ever have an issue like this again, because my first thought was a voltage drop, and that's what's causing the starter to release, I'm going to do a quick check on the block for voltage drop. I mean, I do this all the time, the voltage drop checks to the block, because we see negative cable issues and battery cable issues all the time. But it's funny how you can do a test and you can just, oh, yep, none of that stuff's bad. And that's what we thought when we jumped that starter. Like, none of that stuff's bad. We'll just skip over it. We're looking elsewhere. We're going down a different path. So that's why I'm sharing this one, though. It's the sort of thing that we run into as technicians. You know, you can define exactly how you might walk through a problem on paper, and it looks great, it sounds great, it's technically accurate, but then you get out there in the real world, and man, these cars will throw some curveballs at you. And especially when it comes to control modules, you don't know exactly how they're going to react when there's a problem. And there's so many different problems that we can introduce to them, right? I've seen hundreds of these little Focuses and Fiestas, and I've never seen it do this exact thing. And maybe I never will again. Who knows? Maybe I will. I hope I will, because then I'll know exactly what to do. Funny enough, actually, I went to a Land Rover later that day, and it didn't crank. And it was like the first thing I looked at. I'm like, oh yeah, I'm going to check the ground. And this one was funny because I took my test light on the negative battery terminal, right? The clip ends on the negative battery terminal. I touch my test light to the block and it lights up. And I'm like, okay, all right. And they just left a cable off of the transmission. So that one wasn't as fun, but you know, it's just those weird, unique problems. You don't know if you're going to see that exact scenario again. But I learned a lot about the system, and it's now burned in my memory in case I get into something like that again. And hopefully it helps you out. Maybe it helps you think about it. Maybe it's something that you can look for, or at least consider, you know, when you're having this type of issue with the vehicle. Maybe you just think I'm a dumbass. You're like, Sean, why didn't you just check that in the first place? But that's the way it goes. So we ate the ECM, but that's just the cost of doing business. And we'll just continue to strive to do better in the future. That's all we can do. So I want to thank everybody for listening. Really appreciate it. Hope everybody's out there making some money, doing great in the automotive world. But with that all the way, let's get out there, start fixing the world one car at a time.